WarsawJS.
Please give a warm welcome to Krzysztof Wojnarowski.
Yes.
Thank you.
Okay. Hi, everybody. I am Krzysztof Wojnarowski. I'm an engineering manager at Box, and thanks for having me here, letting me speak. And this is our temporary space. So as you can see, it is a little bit ad hoc. Next month we are moving to the bigger place. So hopefully, Piotr will agree to host to have WarsawJS at our new place as well. So, yeah. So without further ado, today I'm going to talk about building a platform game from scratch. Basically, I will tell about the idea of creating a game. There are a lot of games, so why to create another one? I will touch a little bit on the main loop. So this is the place where all the magic happens. Then I will touch base a little bit about assets. So how to make things smooth, how to put the graphics into life. Then we go a little bit deeper into the implementation stuff. So this is the cool details. This is what I like. That brought me most fun in creating the game. And last but not least, we will touch a little bit on optimization. So the idea. I wanted to check, since I was a kid, how does game engines work. I want to make my own game. So I wanted my game to be all-time classic, and was very ambitious about that. And those ambitions were mitigated very soon, because I realized that I have zero graphic skills. I have absolute none knowledge about the game dev. So I ended up in reducing the expectations to creating a small two-dimensional platform game with several enemy types, with randomly generated levels, several weapons, some adjustable difficulty. And since I wanted to learn how to write a actual game engine and how the games are working under the hood, I decided to use as little external libraries as possible. So this project has a couple of years, so the only library that is used is require.js. Some of the older guys might remember it. So the main loop. Before we go there, if you are interested in creating or games, you can just type in JavaScript game engines, and this is a GitHub repository where you can find dozens of them and read through them or implement your game without going through any kind of a pains that I went through. But with implementing your own game engine, it is like with pizza. A lot of people did that before, but you want to be the next one who does it. It's not a rocket science, but you want to do it on your own. So getting back to the main loop, all games have this main loop, and they are encapsulated in that loop. That loop divides, is consisting of two parts. One is for updating the state of the game, and the second part is for redrawing everything. On the update, we have to update everything. So in case of our game, we have to update the main hero, the guy that walks. We have to update enemies, and we have to update the surrounding. Updating the main hero consists of updating the effects that are from the input. So if we press jump, then to tell our hero to jump. Then we have to apply physics on top of that. So if we have collisions or if we have gravity, we have to update the state with that gravity. Then we have to update all the collisions with ammunition. So because we want to kill enemies, and we do that with ammo, and this ammo has to collide with an enemy in order to distinguish if it's if the hit occurred, and then we have to update the AI. We will get into each of those phases like on the next steps. But like the main idea is that we have the main loop and we have like this update and redraw parts. And for update, we just iteratively apply all the engine rules to all of the objects on the level. Regarding the redraw part, the thing we do is we just get all the assets, all the visual representations of our elements in the game, and we draw them on canvas. We have this put image method. We just putting a background, then on top of that we put level, enemies, elements that we can pick up, hero, ammo, effects, and then this hood, so we can have like some stats. To trigger this this tick and each step of the loop, we use a request animation frame, which is basically available function of window. And we repeat that over and over again. But the fun part is like further on. Before we move on and go to assets, so like how to make our our game alive and like how to process the images, I would like to thank like the folks that I basically took the assets from. I used the open source code and it's on GitHub. So all the characters are taken from Macron's repository, and I took background from Natmoney from DeviantArt, and I asked my friend Krzysztof Wojnarowski for creating all the other graphics that I couldn't find on the internet, because I told you I'm very bad at graphics, so I had to take it from somewhere. And I took it, and legally. Okay, so getting to an assets. The character that we want to put into our game consists of two things. One thing is this like representation, image representation, which is called sprite, and it consists of all possible positions that like our character can do. They are started here in the rows, so each row is sequence for each action. For that, we create an object and just point out all those actions that we have. So we can walk left, walk right, we can stand, jump, and so on and so on and so on. And we just like bound the actions with like position on the image, where it starts, and with the width and the height. So as we will iterate through in our loop, as we will iterate through the next frames and like calling this request animation frame, each time we will request different frame and we will redraw different position of an actor, so we will get the impression of movement. And this is the part regarding the representation and the movement of our hero. Second thing is that that I added here is just like additional info, like health, which is called stamina here, like maximum health that we can have, like weapons, and so on. We can put whatever properties we want our actor to be described with, and encapsulate them in this in a single object. Then redraw it, and now we are getting into the cool details. So remember, at that loop, we had to apply physics, apply keyboard, and apply collisions. So we have to implement them. Regarding physics, like first thing that like I encounter while doing collisions is that in some cases, when objects were moving between two positions which were like updated between the redraw parts, they were moving so fast, so the collision wasn't detected. So for that, in order to detect collision, we have to think of something which I called like a speed of light. And this is the maximum speed that character can move in order to detect collision between two positions. And just a question, is that clear?
Almost.
Okay, so if you have like a question, so bring it. No, it's almost clear. Okay, because thanks. Okay. How to implement that speed of light? Basically, we are taking two smallest objects that we want to put in our game, and the tick, like the time quantum that we use in our game, like this dt, and the speed of light has to be smaller than the smallest dimension of our object divided by this quantum. So basically, that will give us the limitation, and this is one way to do it. And the second way to do it is that we can like implement it. Basically, make a function. If something moves faster than xyz, then make it go slower so we can detect the collisions. And this is the easier way. I came up with the easier way like a few months after I implemented the old way, so it's not here. Regarding this speed of light, as you can see, here is like the part of implementation. If the velocity is too high, then reduce it. And here is the physics. So we have our gravity. So first of all, we check if the if actor is like moving slow enough to apply the gravity. If it does, then we apply the gravity. So we have this nice effect because our actor has to stick to the level. Whenever like level drops, actor drops as well. Next thing is collisions. So for that, there were like two kind of collisions. One of the collisions is between like ground and actors, and this is basically this is an equation for checking if the two squares are overlapping, and this is the one on the left. And second one was to get a little bit like easier to get the collision with the ground, because when actor approaches, when our hero jumps on the level, if the collision would be like two-sided, then he would jump and like hit the level with his head. If you want him to jump over it, we have to remove some parts of this equation and just basically shift it a little bit so he collides only if he's falling from the top. Another thing that another type of collisions that we had to like implement was collisions with the ammunition. And since those collisions that were like in the previous slide here, this equation looks quite, it's a simple if, but it is like quite consuming if it is about the complexity and like usage of the processor. So if we want to do that over and over again for each actor, so we are losing a lot of computing power. So if we don't have to, like in case with ammunition, we just do the one-dimensional collision, and we check only if this one-directional ammunition like is colliding with a square. Another thing that I wanted to add, because physics wouldn't be physics if we wouldn't have friction, is friction basically, which is just a factor that reduces our velocity each tick if nothing happens. So if I let go of the go left button, then each iteration of that loop will reduce the velocity of the actor by factor 0.9. And remember the loop at the very beginning? There was a loop on updates. We have to apply all of those checks on each actor and on each ammunition. So this is like quite heavy operation, but we have to do it in order like to update the state of our actor. And yeah. In order to optimize that, we can do several things. First, we update the physics after we update the state of an actor from the keyboard. Then second thing is we optimize only, second optimization is that we update only what we see in the viewport. So if we have a level that is like quite long and we don't have, I didn't, dynamically generated actors, we update only the ones that are in the viewport. And next thing, what like I was very mostly excited about implementing the game was the AI. First idea was to let's use something like fancy, like genetic algorithms. It was back in the days, they were still fancy back then. Now they're not. And then I decided, okay, it will optimize only for like average solution, and you have to implement that. And then I went, what a bummer, I don't want to do that. Next, it was neural network. The same issues. You have to implement it, you have to train it. So a lot of work, and it's only two-dimensional platform game. Another turn was to like the expert system, but for that you have to like get all the states, build the state machine, a lot of implementing, and still it's a 2D game. So I ended up with ethology. And it turned out that ethology is quite fun thing in order to implement a simple artificial intelligence, because if you add some factor that is like kind of random, then you can alter it. And adding that condition at the very beginning, you can shift the difficulty level. So if we have high difficulty level, then actor will react, like the enemy will most probably react on the situation that is surrounding him. If we have low difficulty level, then he will just stand and don't do nothing. And this is how we can like easily shift between the difficulty levels. And the only thing that we implement is conditions on like certain situations. So if like our enemy is close to us, then he hits, or if he's like his health is below some level, then he runs and jumps away. That gives like a cool. This is sufficient for that. So feel free to go for that solution. Don't try anything fancy, really. Yeah. Next thing was generating the levels, and as I mentioned, I know nothing about graphics. I am very lazy. I didn't want to implement the whole level, draw it, or like put it down as a code. So I decided that I will randomize the levels. So how to create a randomized level? Basically, first of all, is you have to go with your custom random function. And why custom random function? Because if we have level 1, then we want level 1 always to look the same. However, it is random, but it has to always look the same. If we would use math random from JavaScript, then this first level will always look different. Why is that? Because you cannot predict the starting point of a random generator that's like built in JavaScript. It's not seedable. So you have to implement your own. And actually this one is based on logistic map, and it's random enough. And the only thing now we have to take care about is to generate the level that actor will be able to walk on. So we have to, if we are putting the level based from the consisting of some, let's say, platform parts, and they are connected, they will have slope. And that slope cannot be too hard, too stiff, because if it will be too stiff, then the actor will stuck in it. So in order to mitigate that, we can we add some like allowed factor of stiffness. It is like allowed change factor. I don't know why I call that, but it mitigates the slope stiffness. And then we do our in for loop. We are generating randomly like parts, and then we are adding that to an array, and this array is becoming our level. Simple as that. And this is about like this, like parts that that we need to take care about for this update and for the things that are for this updating and like keeping the state of our game. The thing that is mostly like related with this redraw part is our camera. Our camera basically is where what we show on the screen. For that we I defined like some small object which is which has like position, perspective, and like width and height. And when we initiate that, we are pointing it at our actor in order to trace it. This factor here, like in this, I will go. It's not this slide, okay? Sorry. Yeah, in order to trace it. This factor here, camera position X, this here, is what keeps the camera on the actor. And why we redraw the level, as I mentioned, first we draw an image with a background, then we draw a level from what we already generated. Then we iterate through all the actors, and like quick hack, our hero, like our main character, is the same actor as everybody else, but it has keyboard attached. So basically, that distinguishes him from other characters. And basically, this like main part of this redraw function is like draw a level. So because nothing else moves, so we draw everything in this order, because we are putting stuff on canvas. So we are putting background first, then we overwrite it with a level, then with an actor. So this way, we are getting like everything put in the correct order. Regarding how to create an animation and this sprite, remember about it. Like we created this. We had this sprite, and we had like those like frames. And here we iterate and just redraw part of the sprite. So this is like take the part of the sprite at the correct position and draw it on the screen. So this way, we have like one big PNG sprite, and we draw only parts of it, and that creates impression of a movement. And regarding optimizations.
5 minutes.
Okay, so that will be quick. First, don't implement your own functions, use the built-in ones, and don't fall into the tricks like, oh, bitwise operators, they are probably quick. No, they're not. Here's an example that I came up with that bitwise operators for like rounding numbers are not so quick. You can much better if you like math floor or math round are much faster than that. That was a big wow for me. Next thing that regarding optimization, create helper variables, avoid changing references. So whenever you have a loop, when you have to refer to an object and to some property of that object, or you have nested objects, first try to define a helper variable that will store this reference in order for compiler for engine not to have to find that reference each time he iterates through that. Second thing is update only visible parts of the level. Simplify meshes and collisions, because I didn't say about that. At the very beginning, I wanted to have headshots, and headshots would require much more complex collisions, and frame rate dropped to several frames per second. Follow the design patterns. If you see my code on the GitHub, you will see that it doesn't. So this is lessons learned. Because follow the design patterns. If you don't, then debugging will get a hell. And this is not only for developing games, everywhere. Please follow the design patterns. You don't get used to one. I got used to dependency injection here and and composition. Not always the case, but I used it by force. Don't do that. Follow the right design patterns. Another thing is to simplify physics, approximate what you can approximate, just reduce as much as you can number of computations, and remove unused objects, like ammunition. If we are shooting somebody, then we are spawning an ammo. This is an object that is represented in memory. This is the object that you have to update each time you iterate in your loop. So if you leave that alive, after shooting several hundred of rounds, you will get significant decrease of the performance. And scale your graphics. You can use zooming functions, and that will put computing on the GPU, not the JS interface. So you basically put less pixels into. You have to handle less pixels, put less pixels on the canvas, so you lighten up your game and put this responsibility of displaying huge image on the GPU side. You will lose the quality, but for two-dimensional games, it's good enough. So, questions?
So, Mr. Wojnarowski, yeah, Grzegorz, here we go. What's your question?
I have two. Is it working?
Yes.
Okay.
It's only being recorded.
Okay. So there are two questions. First, is this game somewhere to download?
Yes, it's available on my GitHub. So go github/Krzysztof Wojnarowski, and it's only repository. You will get the origin, and you will find my secret repositories if you follow the one that I forked it from.
Okay, thank you. And second question, is the HAL 9000 who appeared during your presentation one of the bosses or final boss or something like that?
Unfortunately, no. With this AI, based on several ifs, it wasn't possible.
Another question. Next question. People seem very interested in your game, apparently.
Yes.
There's a whole mob over here playing it, so there's something to be said for that. Anyone else have a question? I need you to take this microphone. Can you reach forward? Okay, there you go.
Hi. Could you tell more about design patterns that you mentioned in one of last slides?
Okay.
I'm very curious.
Okay. I got both now. Regarding the design patterns I use, I, let's say, overdosed dependency injection. This is one thing. I overdosed interfaces. And at one point, the thing that I'm quite okay with is that I used the factory pattern for creating new enemies. So if you go to the code, you can see the implementations. However, don't learn from it, because like those patterns, I was a fan of dependency injection and like interfaces back then. So I misused them in several places, and you can see how it is done. It works, but debugging is still like a bad thing, because you get an error at the very end of the funnel instead of at the very beginning. So that's why I state use design patterns for the purposes that they were designed to. Don't use them because you like them. Okay. Is that like helping? Was that welcome?
How's the double microphone? Is it an issue? Okay. Louisa, you're the boss. You just let me know if we have any issues. Okay, we have one more.
Great game. If I run out of arrows, how can I regain them back?
If you run out of arrows, first thing you have to do, you have to deep dive into the code and just increase the amount of it and reload the game.
Okay, thank you.
Basically, it works like this, or you can. There is this. Like you have to. I didn't add that because I didn't have like representation for an ammunition, but you have in the game code you have this pickable, which is like health. So copy paste the code and state that it adds arrows.
But doesn't it like stop the progress of the game? You need to start from the beginning.
If you run out of arrows, you're done.
That's it. Finito. Caputo. Okay, is that it, or does anyone have one more question? We might have time for one more quick question before our next speaker. You have one? Here we go. Michał, right?
Yeah, that's true. Hello again. So my question is, I understand that you implement the seeded random generator for the purposes of generating consistent levels. And can you talk a little bit more on how exactly, is it like based on noise, on something else?
No, I had this presentation because in December I had a presentation on pseudo-random number generators, and it should be like available somewhere. I was speaking about that on WarsawJS, and I had questions about the game, about the game that I used it in. So that's why I came up, hey, maybe I will tell about the game next time. So this is the follow-up. If you are interested, let's meet afterwards. Give me your email, I will send you the presentation.
Krzysztof.
Yes.
Wojnarowski. Everyone give a big hand to Krzysztof.
May I have two things?
Fantastic speaker. No, go ahead.
Okay, folks, I have two things to say. First is I have never seen like so many people playing that game. So thank you, really thank you very much. And second thing is I'm hiring for my team. So this is like kind of an advertisement. Reach me out.
Listen, folks, you know what? Thank you very much. Yeah, maybe it'll go viral, guys. Spread the game around. It seems like it's very interesting. Okay, so thank you again.